So in section 6.2, we're applying NPV and IRR concepts. We're supposed to calculate the net present value of Baldwin Company's expansion, where they buy a new machine, put it in a warehouse, and we had to calculate all kinds of things. So we had to calculate the after-tax salvage value of the new machine. We needed to get to net income so that we could calculate taxes. Then we calculated operating cash flow, investment cash flow, and at the bottom line, we calculated the total cash flow associated with the project and calculated NPV and IRR associated with that project. Now, in section 6.4, we're going to do something similar, except the setup is a little different. It says 6.4 cost cut. So again, we've got the same company facing a different scenario. Instead of expanding, they need to cut costs. They are investing, again, 100K in a new machine, but this machine is going to save, let's actually change that to $50,000 per year in materials. The machine will replace existing machinery. It has no salvage value. It will last 5 years, depreciate in a straight line. And the machine will not affect net working capital, same tax rate as before, should they buy the machine. All right, so we're gonna have to do similar calculations. Let's insert a couple of actually not not big row like that, not the thick row. So let's actually click here. Do shift space to select that column, control shift plus to insert, let's insert lots of rows. Yeah, I think that's probably enough. And let's copy everything that we did here. And we'll see some of this we may, oh no, actually, let's go to the solution where we already worked it out. So let's highlight all of this. So let's go down and all the way to, yes, to us calculating the NPV value. Control C. Let's go down here, cost cut to NPV. Let's place it here, Control V. Perfect. Some of this we will need, some of this we won't need. We certainly don't need units per year, price unit, tax rate, we're going to keep. So we're going to delete just these rows. Unit production costs. So now we can change that. Not the unit production costs. We don't have productions per unit, production cost per unit. We just have that overall, this new machine is going to save 50K in materials. So we're going to say production costs, and now they're going to be negative. So the additional production costs will be negative 50,000 per year. I'm going to Control R all that. We have nothing about no increases in those savings over the course of the year, nothing with the net working capital, depreciation of the machine we're going to need. So we're going to just delete these rows, Control minus. Depreciation of the machine is in a straight line, so it's going to be 20% across all 5 years. Cost of the machine is still 100K. There's no warehouse, there's no pre-tax salvage value, so we can delete those rows. We actually don't need this table either, because we don't need to calculate basis, we don't need to calculate net working capital. So let's delete all that. Same thing with the salvage value. Control minus. Now we're going to calculate net income. Sales revenue. So sales revenues don't change. So buying this machine doesn't change sales revenue. So incremental sales revenue is 0. I can just Control R that across the board. Operating costs. The incremental operating costs are now 50K from here, so we can Control R that as well. Depreciation, let's calculate that. That's the cost of the machine, which is 100K. F4, because they're going to be copying that cell, times the depreciation rate is 20%. Perfect. I'm going to Control R that. Income before taxes. is 30,000. That makes sense because we're dropping our operating costs of 50K. We're increasing depreciation expense on net before taxes. Our income rises by 30K, which means that we'll have to pay taxes on that additional 30K, which comes from the tax rate up here, which we lock times 30K. So we pay extra 6,300 in taxes. Fantastic. And this is the net income. Sales revenue, again, incremental sales revenue is 0. Operating costs is here. This additional tax, these additional taxes. And then we have operating cash flow, $43,000. Okay, so this looks like a pretty good investment, because if it costs 100K, really in less than 3 years, we're going to get our money back. But let's calculate the NPV. The bowling ball machine that was, let's call it something else. Let's call it a material saving machine in this scenario. We spent 100K on it, but unlike in the previous scenario, we get 0 at the end. So we can change that cell to 0. There's no net working capital. There's no warehouse. Let's delete those cells, and the total cash flow of the project is going to be just the sum of all the way from operating cash flow to the investment cash flow. I'm going to hit enter on that, Control R, and there it is. That's the series of cash flows. Let's calculate the NPV of that. So first cash flow, we have to hard code plus NPV of this discount rate and array of remaining cash flow is right there. So it's a positive NPV. If you want to actually copy that down, let's lock this cell. Let's lock this cell, and we're gonna lock the C28 cell as well. Perfect, and we can copy that down, Control D. Let's calculate the IRR. Yeah, it's taking the correct cells. It's a 33% IRR. Okay. Fantastic. So this is how we can do a cost-cutting project. This is a positive NPV at 15%. We would have a positive, even higher positive NPV at 0% discount rate. All right. Now, we're asked to consider an alternative scenario. So let's delete these cells. Suppose that now the company, instead of buying can instead buy a $20,000 machine, $200,000 machine, I'm sorry, that generates the same savings but lasts 10 years instead of 5 years. Should we buy this one? So let's create some space again, lots of rows, so that we can fit at least like 30 rows or so. Yeah, so maybe even a few more rows. And let's copy this whole thing that we just did. Control C, Control V over here. Okay, so now this machine, okay, costs 200K. So we're going to keep it at 200K, but it lasts 10 years. So let's let's expand this table to the right. So we're going to do Shift key, arrow right, 1, 2, 3, 4, 5. Control R. Let's see, does it work? Yes, it just copies the 50,000 savings. We do need to change the depreciation rate because it lasts 10 years and we depreciate it in a straight line over 10 years. So we have to depreciate it over 10% per year. So let's change that. Control R. We're at 10 years. Fantastic. We also need to change this table, of course. We're going to expand it. 1, 2, 3, 4, 5. Control R. Let's see, does anything need to be changed? This actually looks all pretty good. So this machine just generates 31,000, yes, 31,600 of net income, but it does it for 10 years. But let's see, something is off. The depreciation is off. Yeah, the depreciation, when we copied the cells, it still, that cell is locked to the cost of the 100K machine. We need to change that to the $200,000 machine, which is in C41. Let's do that. So copyright, Control R. Yeah, it's a $20,000 the depreciation. And so now the net income, the incremental net income is actually the same as before, except it lasts 10 years instead of 5 years. So now we can calculate cash flow. Of course, we're going to need to expand this table as well. 1, 2, 3, 4, 5. Control R. I think everything is okay. This is the cash flow. Let's change the formulas for calculating NPV, because those formulas were also locked. So we're going to change it now. We need it's not C28, but C60. And B63 is fine, but we need D60 to actually not H28, but actually M60. Let's see, is it really M? Let's scroll over. Yeah, the last cell is M. So that's the NPV of this project. We can calculate IRR. IRR looks 3%. It takes C60. That's correct. We can actually copy this down. Control D. Something is off. NPV of B C60. See, so the IRR. Oh no, the IRR is off because we need not H60 but M60. All right, yeah, and then at IRR, that's the discount rate. At the NPV is 0. So this makes a lot of sense. So now we find that the NPV of this project, the 10-year machine, is $19,000, and the NPV of the 5-year machine is $46,000. Now the problem is that if the two projects have unequal lives, NPV is not appropriate metric. And we can illustrate that by doing one more scenario, by doing a scenario where we change things up. And instead of having one machine that lasts for 5 years, we're gonna have that machine for 5 years, and then we're gonna replace it with another machine that lasts 5 years. And that way we'll get a project that has the same length, just 10 years. So let's delete, Control minus, actually one more, Control minus. So how will things change? Let's see. So we can actually copy again all of this, these 10-year tables. They will be pretty helpful. I'm going to do Control C here and copy that here, Control V. So So the savings are still $50,000. The tax rate is the same. The machine, though, is now $100,000. 1, 2, 3. It's depreciated 20% per year. So yeah, we're gonna keep it this way. Control R. We know that we're gonna have to buy this machine twice. We're gonna keep that in mind. That's not coded in this table yet. But when we calculate the investing cash flows, we'll have to remember that this is the initial cost of the machine, but it's gonna die. The machine's gonna die in year 5, and we're gonna buy a new one. We're gonna buy a new one at the end of year 5. So, but sales, depreciation, and all of that. Let's make sure that we have that correctly. This needs to be adjusted. It is 20% of, again, we're back to $100,000 machine, which is in C72. C72, perfect. And we're gonna control that. All right, Control R, and yeah, now we're getting 23,700 in additional net income. That looks all good. Incremental cash flow, the operating cash flow, there's our 43,700. That doesn't change. However, the investment cash flow, now we have the material saving machine. We pay 100K in year 0, and then we pay again minus 100,000 at the end of year 5. So, and then that machine again dies in year 10. So instead of having 200K 10-year machine, we have 200K 5-year machines. All right, let's calculate the NPVs, and we know those formulas were locked, so we're going to change them again. So we need C91, 91. We need D91 to M91. That should work. We're gonna Control D that. We're gonna do the IRR is correct. Fantastic. So this is at 15% discount rate, 20% discount rate. Well, let's actually change these baseline discount rate. Let's make this 10. Let's make this 115. Let's do the same thing over here, 0 and 15. 0 and 15. So what is going on? So if there's no time value of money, then the net present value of 2 times 5-year machine is $237,000, which is the same as the value of $200,000 10-year machine. Okay. So if the timing of cash flow does not matter, then we're really indifferent whether we buy 1 10-year machine or 2 5-year machines. However, if we have some time value of money, if we use a discount rate of say 15%, then the NPV of the 10-year machine is 19,000, whereas the NPV of 2 times 5-year machines is much higher, much higher. Intuition for this is that with the 10-year machine, we're paying 200K right up front. Okay, right up front, and the benefits of that will come very, very late. They come, in over 10 years. With 2 times 5-year machine, we pay only 100K upfront. We captures the benefits, and then we pay 100K only 5 years later. So clearly, when there's a time value of money, the 5-year machine, buying 2 5-year machines in a row is better than buying one 10-year machine right at the beginning. I mean, the 10-year machine would just have to be, a little bit cheaper, not twice as expensive, or we have to generate higher savings. There's another way of coming to the same conclusion, and that is called equivalent annual cost, okay, EAC. And the equivalent annual cost is calculated as the value of payments that are equivalent to the net present value. So you can, when you think of those arrows that we draw when we calculate time value of money problems, we could see that the benefit of 118,000 today could be translated into equivalent payments over the next 5 years, since this is the 5-year machine. So we can calculate that using a PMT, where the rate, let's use this one, 0, number of periods is 5, PV is 118,000. There's no FV, and well, sure, it can be explicit. There's no FV, and end of the period 0 is the default. So let's calculate that. So the equivalent annual cost, or in this case, equivalent annual benefit of the 5-year machine is 23,700. We can calculate that, Control D. Clearly, if we have a really, really high discount rate, then there's no equivalent annual benefit. Good. If we have a 15% discount rate, the benefit is 13,868. Let's calculate, and we can actually copy these cells. I'm going to do Control C and copy them down here. Control B. We could see that for the 10-year project, well, we have to change one thing. Actually, we have to change, now this is a 10-year project, so those payments will happen over 10 years. Because that machine lasts 10 years. So let's Control D that. We get that with 0% discount rate, the equivalent annual benefit is the same if I do one-time 5-year machine or one-time 10-year machine. But if I have positive discount rate, then clearly the annual benefit is much higher if I just buy the 5-year machine rather than the 10-year machine. In other words, this 13,000 is much higher than the 3,000. Let's copy these cells, Control C. Let's copy them all the way down here, Control V. All right, now we see that with 2 times 5-year machines under 0 discount rate, it's the same benefit as one-time 5-year machine or one-time 10-year machine. With 15% discount rate, 2 times 5-year machines is the same equivalent annual cost as one-time 5-year machine, and it's much higher equivalent annual benefit in this case because it's a positive number, is higher than the 10-year machine. So if we have projects that have unequal lives, one is a 5-year project, the other one is a 10-year project, a good metric to compare the benefits of those projects is to look at the equivalent annual cost. In this case, clearly comparing this 5-year machine, equivalent annual benefit is 13,000. doing the 10-year machine, the equivalent annual benefit is only 3,000. So clearly doing the 5-year machine is better than doing the 10-year machine.